when we look at our diet, I mean, it is true that we're taking kind of a orthomolecular approach in that we want the right amount of nutrients in the right doses, to exert the right action. So we are tinkering, as you say. I mean, it's kind of it's exciting the way that you put it. But if you zero out and look at our diet, the nutrients have very long traditional use histories.
Well, hi everyone. Dr. David Perlmutter here. Welcome again to our program, The Empowering Neurologist. Interesting program today. We're going to look at the whole notion of aging, of longevity, but more importantly, of not increasing our lifespan per se, but increasing our health span. And I think right off the bat, one of the things we have to talk about is how do we measure lifespan? How do we measure our biological age? Lifespan is how long we live. Biological age is really how much aging our bodies have endured. And, there are a lot of things over the years that have been looked at that were correlated, or attempts were made to correlate things like the oxidative damage to our DNA, even hemoglobin A1C, other markers, and more recently, telomere length, of course, something that's been looked at as a marker of aging with attempts to increase our length of our telomeres, the end caps of our DNA, if you will, in hopes of having an impact on lifespan and, more importantly, health span, how long we remain healthy, trying to compress our disease span or our period of disability at the end of our lives. But I think that what we're seeing now is the utilization of a far more sophisticated test, which looks at how the pattern of change of our DNA changes over time. Our DNA, our life code, binds groups of chemicals called methylation groups in various patterns. Some of them are increased as we age, and some of them decrease as we age. And this methylation pattern of our DNA has been characterized in such a way as it now looks like it very much correlates with biological age, how rapidly our bodies are aging. And we call this, based upon the researcher who really is credited with getting the science to us, the Horvath clock, after Dr. Stephen Horvath, who characterizes the unique pattern of these changes to our DNA and has drawn very specific correlations with these changes over time and our biological age, and even as a way of predicting when we might die. He calls that the grim age. We're not going to be talking about that today. We are going to be talking about using the Horvath clock, the DNA methylation clock, in terms of how it might be altered. And we are going to review a new study. I'm going to read to you the name of the study. It is Potential Reversal of the Epigenetic Age Using a Diet and Lifestyle Intervention, a Pilot Randomized Clinical Trial. And what Dr. Fitzgerald, the lead author on this study, did a measurement of these individuals who participated in the study, biological age, their methylation of their DNA pattern, if you will, beginning of the study, and then remeasured these individuals in comparison to a control group after an 8-week intervention during which various lifestyle changes were made. Meditation in the form of a relaxation program, breathing exercises, if you will, paying attention to their sleep, their exercise, certainly their diets were changed as well. And the results were really quite remarkable. And we're going to talk about the implication of the results as well as the design of the study, what it means to all of us when we get together with Dr. Fitzgerald in just a moment. But let me tell you a little bit more about her. Dr. Kara Fitzgerald received her Doctor of Naturopathic Medicine degree from the National University of Natural Medicine in Portland, Oregon. She completed the first Council on Naturopathic Medicine accredited postdoctorate position in nutritional biochemistry and laboratory science at Metametrics Clinical Laboratory under the direction of Richard Lord, PhD. Her residency was completed at Progressive Medical Center, which is a large integrative practice in Atlanta, Georgia. She is the lead author and editor of Case Studies in Integrative and Functional Medicine and is a contributing author to Laboratory Evaluations for Integrative and Functional Medicine and the Institute for Functional Medicine's textbook for functional medicine. With the HFGOT Research Institute, Dr. Fitzgerald is actively engaged in clinical research on the DNA methylome, which is what we're going to talk about today, using various dietary and lifestyle interventions that she has developed in her practice. The study that we will talk about today was published April 12th, 2021 in the journal Aging, a consumer look and application-based program with DNA methylation assessment are scheduled to be released in January of 2022. Dr. Fitzgerald is on the faculty at IFM, the Institute for Functional Medicine. She is an IFM certified practitioner and she lectures globally on functional medicine. She runs a very popular functional medicine clinic immersion program for professionals and maintains a podcast series, New Frontiers in Functional Medicine. Her clinical practice is in Sandy Hook, Connecticut, and we are delighted to welcome Dr. Kara Fitzgerald to the program today. Welcome, Dr. Fitzgerald. How are you doing?
I am great, and I'm just really thrilled to be with you today, Dr. Perlmutter. It's always fabulous to spend some time with you.
And, of course, we'll jump into all the cool stuff. But again, it's great just to connect every once in a while and see what we're all doing. And, I never hear that you're not doing the coolest stuff out there. And this new study is no exception, leveraging, really the state of the art in terms of what we understand about longevity, about compression of the disease window at the end of our lives, increasing our health span. And so that in the intro, I talked about that, sort of gave our viewers a taste of the methylation clock, the Horvath clock, and et cetera. But let's just jump right in. So first of all, why did you do this study?
That's a great question. And I'm going to give you my background and just, feel free to kind of cut me off because I can wax on about this for the next few weeks. We're in functional medicine, we're in systems medicine, and I have a laboratory science background in addition to a clinical background. And so, we've been paying attention to our ability to look using laboratory testing much more precisely. I mean, I would say we're really in a revolution now with our ability to sort of analyze the oome, be it the microbiome or the genome, or in our case, the epigenome, one of the newest areas that we can look at with, just extraordinary depth. And so with that, with this new ability, of course, publications are coming out left and right. It's such a growing science. It's extraordinary. And, I'm going to say around 2013 or so, I mean, it's something we talk about it in functional medicine, but I knew I needed to really do a drill down into the science. And the area that the science is the strongest on is certainly at that time, I was looking at cancer epigenetics. And so the tumor microenvironment really takes over epigenetic expression and, epigenetic being sort of above the gene, sort of the biochemical processes that regulate genetic expression. So cancer gets in there and takes it over. And I want to say, just in case I don't say it later, it's actually not that dissimilar to what happens in other conditions, including aging. There's sort of these predictable things that happen that aren't favorable to us. So cancer kind of takes over and it turns genes on that it wants on to further its growth. It shuts genes off that, like tumor suppressor genes that are protective. And the area that has the type of epigenetic mark that has the most science behind it is something called DNA methylation. So these methyl groups are put right down onto a gene to inhibit expression, or the methyl groups are removed and then gene expression is turned on. So there's hypermethylation happening where genes are inhibited, and hypomethylation. And as you know, we're thinking about methylation in functional medicine all of the time, and we're addressing methylation with a variety of nutrient, supplement, lifestyle interventions. And so my next question was, could we be influencing epigenetic expression negatively? Do we need to nuance how we approach epigenetics now that we can look at it? And so at that time, me and our director of nutrition here at the clinic, we came up with the methylation diet and lifestyle. We decided we wanted to do a strong food forward approach. So we created a diet that's very methyl donor rich, so lots of greens, beets, all the things that will support methylation. And then we accompanied the diet, that nutrient intervention with polyphenols or colorful fruits and veggies that have their own science behind them in kind of massaging where methyl groups are put on the epigenome. So we're supplying methyl groups and then we're directing where they go, and it's safe. I mean, there's certainly no negative outcome with this kind of a diet. It's actually a really pretty traditional diet. So that's where we got started. We layered in the lifestyle pieces because there's good research there. So exercise, we know, sleep, and meditation practices, all of those lifestyle pieces can influence our epigenetic expression towards the better. And we started to use it in practice. And of course, the next question was, are we really making a difference on epigenetics? It's not a test you can just go send your patient over to Quest to get. It's only, the epigenetic tools are largely only available in the research setting. And so, really by a miracle, just this extraordinary opportunity, we were given a grant, and it was very pricey for us to do the study. And we were given a full grant, unrestricted, so no control of our study design. And we hired Health Gut Institute out in Portland, Oregon to run it. So that's the background of how I got into it. And let me just stop for a minute.
All right, yeah, and let me clarify a few points. You did a great job,
Yes.
but and that is that you're talking about giving a diet that is rich in what are called methyl donors, and what you're saying is really quite remarkable. That you are providing a diet that is offering up the triggers for DNA expression change. I mean, you will admit, as I admit, that our education was such that DNA was pretty much locked up in a glass case and inviolate and determined everything about us moving forward. We began to
Yeah.
see nuances that our lifestyle choices could affect DNA expression around 15 years ago, in terms of being able to feel pretty secure in terms of making certain recommendations. And now you're talking about a diet, and we'll get into it later, that not only supplies those triggers, but positions them and even facilitates the removal of certain methyl groups from areas when the association of the binding of those methyl groups to certain areas to our DNA is seen to be associated with advancing or later age on the so-called methylation or Horvath clock. So it really brings an entirely new playing field of understanding as it relates to our food choices. Over the years, we've said, yeah, your broccoli is a good choice because it's got fiber, which is going to nurture your microbiome. It has, precursors for sulforaphane, glucoraphanin, that we can, activate the myrosinase enzyme and make sulforaphane, which activates an entire pathway, the NRF2, on and on. We've talked about these.
Yes.
We've deconstructed the foods, but now we're talking about how foods, as you just described, are playing a central role in changing the expression of this gift, our life code that we have inherited from all who have come before, and altering the expression of our life code in a very seemingly positive way. So, with that as a background,
Yeah.
then you've got this tool to measure biological age, and you've created this intervention. So maybe
Yes.
just a little bit more on the breakdown of, first, the dietary intervention, the role of the various components in terms of how they would affect the methylation pattern.
Okay. And again, feel free, David, to just cut me off if I get in a rabbit hole too much. But So we know that we know that the diseases associated with aging, including cancer, tend towards sort of a global hypomethylation pattern. So we knew at baseline that our diet had to be very rich in, B12, in folate, in betaine, in choline, those nutrients that spin the methylation cycle and produce that methylation cofactor SAMe, and people have certainly heard of S-adenosyl methionine. It's made in our methylation cycle, and then SAMe is used all over the body in these methylation reactions, these methylation transferase reactions, and for our area of interest, it's happening at DNA. It's happening in genetic material, mitochondrial DNA and the DNA actually in RNA, and in a variety of ways it's happening there. And so we know that as we age, we need to be supported with methyl. We need to be supported with methyl donors. And so the baseline diet had to just be packed with those nutrients. We include liver for, a little bit of liver. It's not an animal heavy diet, but that liver is an extraordinary multivitamin for folks who can source clean liver and are willing to eat it. Eggs, and again, greens, lots of beet greens. Mushrooms, amazingly enough, maitake, shiitake, enoki, these are, again, almost like methyl donor multivitamins. I mean, they're just extraordinarily packed with nutrients. And then onto that is curcumin and green tea and blueberries and resveratrol, quercetin, luteolin, these beautiful polyphenol compounds that appear to take the methyl groups that they're getting from the first group of foods, and kind of, we're thinking, perhaps our study is suggesting, sort of directing that they go to these more favorable sites. And so that together forms the foundation of our diet. And let me just stop there and see if you need more and what.
Sure. Well, let me say that you're tinkering with, in a positive way. There was nothing derogatory about that, but the idea of assisting with the transfer via activation of DNA methyltransferase using things like curcumin and EGCG from green tea is really, you're the master puppeteer here. You're not only supplying the methyl groups, but you're, in a sense, activating the enzyme then that says, okay, we're going to put you somewhere where you belong. And at the same time, working to perhaps relocate those that have accumulated in areas, I hate to say that they don't belong, but do seem to be associated with age.
Yeah.
So it's you are actively manipulating. That's what the purpose of your study was and is, the methylation pattern of DNA to bring about a more, may I say, youthful pattern of that DNA fingerprint, methylation fingerprint, and using lifestyle. So by all means, let's move to what would be next. You talked about exercise, and you had people exercising 30 minutes at what, 80% max VO2 or something like that for at least 5.
Yeah. Let me
Sure.
just back up, and then we'll talk about exercise. But I just wanted to, when we look at our diet, I mean, it is true that we're taking kind of a orthomolecular approach in that we want the right amount of nutrients in the right doses, to exert the right action. So we are tinkering, as you say. It's kind of exciting the way that you put it. But if you zero out and look at our diet, the nutrients have very long traditional use histories. Like we've known, and as you pointed out in the beginning, these beautiful, what we're calling methylation adaptogens, but these polyphenols, green tea and curcumin, I mean, these are nutrients with time immemorial, histories of being, active for a variety of indications. So it is interesting what we're able to do and what we're seeing. And we're leaning on, nature and what's known and what's been done, So I just want to point that out, because that was an aha for me in this journey.
Well, and that said, the foods that you're talking about, traditional foods. I mean, my goodness,
Yeah.
curcumin. Um, Ayurvedic medicine talked about it 3,000 years
Yes.
ago, but we've learned over the years, yes, antioxidant activation, anti-inflammatory
Yes.
activity, detoxification activity, and now we layer on the role in terms of gene expression.
Yes.
So there's a huge pedigree
Huge.
here that are stumbling through to learn
Yes.
about. And it gets back to, I guess what mom said years ago, eat your
Yes.
vegetables, and what we've all been told. And certainly, with all due respect, stands a bit in contradistinction to, I think, the focal points of modern medicine, which really don't look at any of these lifestyle issues, but pretty much would dictate to us to live our lives come what may, then we'll fix it after the fact. I mean, to be clear, before the recording, you and I were talking about the work of our friend Dr. Dale Bredesen, who is leveraging a targeted, call it a lifestyle program, to through what's called precision medicine, to actually unwind a lot of the accumulated issues in a person's life, to reverse the cognitive decline associated with Alzheimer's disease. The current therapy for Alzheimer's disease, based upon the model that I just presented, let's live your life however you want, and then we'll fix it with a pill. So in a very real way, you're in that same category
Yes.
in terms of, gosh, getting back to the basics and keeping people healthy.
Yes, absolutely. No doubt about it. And so, um, just, yeah, exercise um, it's as important to DNA methylation, it's as important to genetic expression as any of our dietary interventions. And the research that's starting to come out is extraordinary. I mean, it's acting like there's a very cool study, and I can give it to you for your show notes, which shows, especially as we age, we get more exercise bang for our buck than when we were younger, and it specifically helps turn back on genes that were previously inhibited. So going back to the cancer model, tumor suppressor genes, these good guys, these genes that we want on, keeping us clean, keeping us free of cancer, get hypermethylated in cancer, but they also get hypermethylated as we age. And this very cool study showed recently that the older we are, the more likely exercise is going to allow for the re-expression of these tumor suppressor genes. And I want to say one other piece that we're thinking about in our study is the fact that epigenetic marks are heritable. I know that's kind of a whole new sort of conversation, and we'll see where you want to go with it. But in this particular study, they also showed that preconception, if you're exercising or not, there'll be epigenetic patterns, favorable or not. Obviously, if you're exercising, they're going to be more favorable, that you'll pass on to offspring. So, and we know that that's true with, there are other heritable marks, and that's another big conversation. But I want to say that the data on exercise are strong, and exercise as an anti-aging tool, specifically, again, looking at gene expression. The studies are impressive. The studies that are there are impressive, and the body of knowledge is growing.
Well, let me expand on that point, because I think it's really very interesting. It's one of the things I've thought about in the last 3 minutes of the day before I fall asleep. Just the how big a scope is the information that is necessary to impart on a new human being. We used to think back in the day, what are we talking, 10 years ago, that the information to create that human being came 50% from dad and 50% from mom in terms of the information that they would receive. They would get genes from mom and dad, sperm and egg come together, and that creates a new human being. Well, fortunately, the creation of that next round of human beings gets powerful input from the environment
Yeah.
in terms of everything you can imagine: food availability, food quality, levels of stress.
Yes.
And that information is imparted upon the DNA of that next human being via the microbiome, the organisms that are implanted in that child newborn's gut, via passage through the birth canal, but also through the mechanism that you just mentioned, that these epigenetic changes are heritable, not just to, at least if we believe the rodent research, not just to the next generation, but to several generations down the line. Matter of fact,
Yes.
had an interview just yesterday with Dr. Stephanie Seneff at MIT, done a lot of work on the dangers of the herbicide glyphosate, writing a new
Hmm.
book. I have it right here, Toxic Legacy, right on my desk. And she indicates that, in fact, when you look at offspring of rodents that are treated with glyphosate, you don't really see much in terms of damage. But if you follow their offspring and the offspring after that, so 2 to 3 generations later, you see real issues. So, what you're talking about these genetic markers, it's just a new ball game for all of us, having
Yeah.
grown up in a time, again, when DNA was locked in a glass case, that we can affect. We're talking about exercise. To
Yeah.
think about the fact that while you're running or while you're on the treadmill, whatever it is that you're doing, you are during that moment and thereafter for a period of time,
Yeah.
you are affecting the expression of your life code. We talk about it in terms of turning on the genes to make BDNF to enhance neurogenesis,
Yes.
synaptogenesis, et cetera. But the number of genes activated by exercise that are positive, you mentioned in the context of cancer as well.
Yes.
But let's get back, and then we'll get to sleep and maybe more on exercise. The notion of the design of the Horvath clock, that it's not looking at the entire 20 million methylation sites on our DNA.
Yeah.
But what Dr. Horvath did was painstakingly developed the notion that there are certain areas of methylation. Maybe you walk us through what exactly does it
Yeah.
mean? What did he do in the creation of this Horvath methylation pattern clock?
Yes. Okay. So in our study, we used the flagship clock that he developed back in 2013 and is still the one that's been, most published on and associates most closely with chronological age. I mean, I think it's considered to be the gold standard biological clock tool at this point, given how closely it associates. So, yeah, and there are other clocks that perhaps we can talk about that have other purposes, but this is a good solid kind of workhorse clock for determining sort of where you are health wise, your biological age versus your chronological age. It's only 353. So you just said 20 million methylation sites, and this clock is only 353 sites, but they all change closely with age. And so if you have a fetal tissue sample, it's negative. It's a negative age. And then, on up to centenarians, the methylation pattern is consistent with their age. So throughout our lifespan, your clock will change predictably, your biological clock. And therefore we can, with a good degree of sensitivity, look at it. And I mean, maybe we would think that the genes, the methylation sites that he's including in his clock would be, things associated with like NF kappa beta B or different tumor suppressor genes, or some of the things that we think a lot about as either wanting to just be healthy people or as clinicians in this space. But they're not. I mean, some of them are relatively obscure, but they do appear to really lock in with the aging journey. Um, there's some wiggle room within the clock, though, the biological clock, that suggests because it's not quite in lockstep with chronological age. It's manipulatable. Like we think that we can use healthy interventions and turn it back, or by extension, if we have a chronic disease, we can see an acceleration of biological age as well.
Well, in the early days following the development of the clock, Dr. Horvath, and I had the opportunity to meet with him actually at the very first meeting of the Longevity X Prize, where we were attempting to determine what the parameters might be for awarding that prize. And I think early on, the sentiment was that the clock and the methylation pattern could not be
Yes,
affected by
that's right.
lifestyle. And then, studies began to be published that indeed interventions, I think one that's gained a lot of attention was the overweight or obese African Americans who were deficient or low in vitamin D. With
Yep.
simple vitamin D supplementation, there was a measurable improvement of their trajectory or the changes in their methylation pattern. So,
Yes.
which is obviously great news. I mean, that takes us to
Yeah.
Dr. Fitzgerald, who really hits the ball out of the park by saying, you know what? We're going to leverage more than one variable here. We're going to look at not just your nutrition, but your exercise, your sleep, stress management. Getting back to Herbert Benson, you
Yeah.
utilize his breathing technique. Man, that was awesome. And let's go, if we can, and we're going to show a graphic here in just a moment, but let's get to again, to just summarize, you did attention to people's sleeping patterns, augmentation, making sure they're exercising, nutritional intervention, and a breathing exercise program. And what did you find?
Let me actually add two things to that. We used a greens powder concentrate, so a polyphenol concentrate, and then we also used Lactobacillus plantarum. We used a probiotic.
I'm glad you
Uh,
brought that up.
yeah,
I have to tell you, just before we got on the broadcast, I went down and mixed myself up this greens supplement powder just to make sure I'm paving the way for methylation, which I know it's going to be
good.
enhanced by
Yeah,
talking to you. So there you go. But
good.
let's unpack those two things. Why did you choose any probiotic species, first of all, and then specifically why Lactobacillus plantarum?
Yes. Okay. Well, we definitely know, as you talked about in earlier, I mean, there's no question that the microbiome has, the microbiome, the metabolites produced by our microbiome are influencing us, the host. And we know that they're influencing epigenetic expression. So we want healthy gut, and our diet is going to be supporting a good microbiome. There's prebiotic foods and all of those important things. But specifically, we decided to go with Lactobacillus plantarum because we know folate is a heavy lifting methyl donor. We wanted, participant in the methylation cycle. And Lactobacillus plantarum, in the presence of PABA, so in the gut microbiome, can increase folate production, and we did show that significantly. So again, we didn't use any supplements in this, but our participants did increase circulating folates quite significantly. Was that due to the Lactobacillus plantarum? We don't know because it is a multivariable study, but that's a piece of the puzzle, and that was really fundamentally why we chose it. Yeah, go ahead.
Another thing that Lactobacillus plantarum uniquely, well, not uniquely, there are others that species that are strains as per your strain that can do this, is it helps maintain the integrity of the gut lining, which I think our viewers should recognize is playing such a role in terms of inflammation. So we want to maintain that. Interestingly, as per information to me yesterday via Stephanie Seneff, glyphosate specifically targets negatively lactobacillus pretty much across the board, and to the extent that it allows other species that are less salubrious, or let's say more detrimental in the array of species in the gut, to become more populated. And so, interestingly, because lactobacillus has within it the biochemical pathway called the shikimate pathway, which has to do with the production of aromatic amino acids that is targeted by glyphosate. So here
Wow.
you're adding back an organism that is being taken away by, a pretty pervasive toxin in our environment. Kind of an aside, but hey, it's our show, what the heck.
It's no, well, it's interesting, and I was just reading, I'm sure one of the papers that you referred to, looking at glyphosate in a rodent model, influencing DNA methylation expression across, I think, 3 generations. Yeah, it's really scary. Another piece of our study was we wanted participants to keep it as clean as possible. We really did. You can't we can't avoid that if you want to optimize genetic expression. I think if you want to stay healthy in today's world, you have to be thinking about minimizing your toxic burden. So we did include that in our study as much as we possibly could. We couldn't, if we were going to insist on all organic, we would have had to supply them with their food, but we could guide them towards making best choices.
And as it relates to food, you did incorporate intermittent fasting into your program.
Hmm.
And tell
Yep.
us why you did that.
We wanted it to be keto leaning, and we did see a drop in triglycerides, so that it suggests that in fact we achieved that. Um, well, because the
That was 25%, as I recall,
yeah,
right?
yeah,
That's pretty
yeah,
remarkable.
yeah, yeah. And these are healthy guys. They didn't come to us none, and that's another really kind of cool point of this study. I mean, these were rigorously healthy guys. Um, it was an involved program, so people who were sort of committed to their well-being started it, but we wanted to specifically look at healthy men. So yeah, the findings are significant. It wasn't in a patient population with hypertriglyceridemia where it's going to be fairly straightforward to lower. So it does suggest that they were adhering to time restriction, and it just gentle time restriction, just 12 hours on, 12 hours off food. Plus the exercise prescription. And then the diet was not as low glycemic. And so, yes, because ketones are potently anti-inflammatory, as you know, and, the data on them is that they certainly augment epigenetic expression. I think it's still emerging how they specifically influence DNA methylation, but we know they influence the proteins, the histones that DNA are wrapped around. And I think it's only really a matter of time that we see the favorable influence on ketones and broader epigenetic expression. But that was why we included, we wanted the diet to be intermittent and intermittent fasting and a little bit keto leaning.
Well, interesting, the data that's coming out with respect specifically to one of the ketones, which is actually not a ketone, but beta-hydroxybutyrate in terms of its epigenetic activity. So I think you're right, though. I think moving forward, we're going to be learning a lot more. But
Yes.
I wouldn't underestimate how that might have added. What you had again many variables, but I think that might have been a big player.
Yeah, yeah, it's interesting. Yeah, and this will be conversation I'm already having with people. What do you think did the heaviest lifting? And I'm kind of bullish on, the diet, the methylation adaptogens, the polyphenols, and the very methyl donor rich diet. And we did increase folate, so there's that bit too. We did, but yeah, I mean, it could have been that little snapshot of intermittent fasting and the keto leaning, and yeah, or it could have been the consistent exercise prescription or the meditation habit. I mean, really, all of them. I mean, there was an interesting study out, a couple of years ago looking at meditation and DNA methylation biological clock reversal in a population in Europe, and showed they actually were looking in heart disease patients and a healthy population. And in the healthy population, meditation made a difference in biological age, a modest favorable difference in biological age, meditation alone. And when you look at meditation or yoga or other centering practices, routinely, even in new practitioners, they can have a favorable influence on methylation. In those who are very seasoned, the benefits just increase exponentially. So all of them are, all of our interventions, I think, are pretty heavy lifters. I mean, sleep, gosh, I mean, we see that in human data and animal data, actually both, you can see just one night of significant sleep deprivation will influence DNA methylation negatively. So all of them are pretty heavy lifters.
You were commenting as far as sleep and I think the meditation, probably more along the meditation discussion in your paper about what cortisol or steroids, stress steroids, if you will, their effects negatively in terms of the methylation pattern, and that might
Yes.
be. It's kind of interesting research, but that might be certainly responsible. But you use the term "what's doing the heavy lifting," and I think until now the model has been we're going to look at things one at a time, and maybe ultimately, if two things seem to be working, we'll add them together. And I think what your study design lends itself to, perhaps in the future, is perhaps withdrawing certain issues, certain variables along the way if you don't think they're contributing as much, and seeing really where the heavy lifting is taking place. But I'd
Yeah.
like to think that we're in a place where we're looking at the communal effort here of all these different
Yes.
variables and not really trying to identify the so-called active ingredient. Let's not
Yes.
try to pull the willow tree apart and figure out why salicylic acid seems to be the active ingredient.
Yes.
Instead, I mean, you've got a great lifestyle program here that in so many ways emulates what our my son Austin, what we put together in Brainwash, a kind of a comprehensive lifestyle approach that can help with rewiring of the brain, which to help with decision making. And
Yes.
when you think about it, there's so many. We talked about Dr. Bredesen's work. There's so many approaches now to target certain issues that are utilizing this multi-factorial, multiple inputs to bring about a change. So it really appends the notion of billiard ball Newtonian
Yes.
mentality in terms of helping us feel better.
Yes, and I want to just say that it's illusory, I think, anyway. Now that we're at the level of sort of teasing out the exposome, all of those individuals in that clinical trial have, myriad influences on them outside of that, that one variable, that one drug, et cetera, that will influence how they respond. So I mean, I think as much I appreciate science, I appreciate the scientific method, and I also deeply appreciate the fact that we're moving into this systems model, this multimodal model. I think it's more authentic and it's more true. And and because we'll never be able to successfully control for a single variable. We just can't. And I think systems design really, and the fact that we're in this omics era and able to look at things so much more sensitively, we're seeing that, that model was a bit of a false flag, as you say.
Yeah, it's a paradigm shift, and I think mainstream science and medicine is going to have a tough time getting their arms around the notion of moving away from the whole single variable mentality. But as you say, you never can completely control. Let
Yeah.
me ask you. You had a description in the paper about your election not to use supplements, as for example folate,
Hmm.
and instead decided to just go with food that you knew would augment its production vis-a-vis lactobacillus or contained folate. And so, why was that election?
Yeah. Why did we opt out? It's an interesting area of thought, and I've certainly debated it with some of my colleagues. But again, when we look at when we think about cancer, which was my entry into really find sort of ingesting epigenetics and thinking about them as a physician, and also wanting to research epigenetic changes. Um, the fact that the tumor microenvironment and other diseases, associated with aging, they can take over epigenetic expression and turn genes on and off, and they're doing that via methylation. And we in our medicine treat methylation, address methylation imbalances all the time. We prescribe folic acid or folate. We prescribe B12. We can prescribe them, myself included, in very high doses. And Randy Girdle and Waterland talked about this in their agouti mouse study way back in 2003, when that first study was published. They were talking about food fortification and the fact that in fortified grains we're getting folic acid there. And one of their study was looking at influencing genetic expression in mice using B12 and folate, and betaine, and they did profoundly. Obviously, it was it's the most cited study in the history of science. But they ended with a caution in their abstract, saying, are we can we have unintended consequences with some of our interventions? And I think that's where I landed. I as somebody who prescribes high dose nutraceuticals, high dose vitamins routinely, what are we doing to epigenetic expression? Are we always moving it in a favorable way? Could it be actually negative? And they went on to show, Girdle and Waterland, that genistein, which is an amazing, compound from soy. It's so powerful. It's an important polyphenol, and they showed that it acted like a methyl donor in this mouse model, in utero, and influencing genetic expression in offspring. And so I think I began to pause on some of the power of our interventions, and that's what prompted me to want to go with this diet and lifestyle forward intervention. Yep, I still prescribe vitamins, absolutely, because we know that they're needed and we know higher doses are needed. But I began to respect that that we could that the epigenetic piece, that we could be making a difference, that maybe we would be pushing something, in an unintended way, and exerting some negative outcome. And I wanted to be mindful, more sensitive, more nuanced. And the other piece that I'll say too is that when I do prescribe B vitamins now, I'm careful to give them with, green tea or the luteolin or curcumin, et cetera. These sort of adaptogens, if you will, or these modulators to,
Cofactors,
I think,
right?
yeah, really, to just sort of make the journey, safer, and how it's going to impact genetic expression.
There's a lot to think about. I mean, it is not, though, as if moving forward now you do not have a tool to measure the effectiveness of giving, a boatload of methyl donors in a supplemental way versus dietary interventions, because you do have the access to this methylation clock, this methylation map, if you will, that lets you know,
Yes.
am I doing the right thing or doing the wrong thing? So in that sense, it's kind of taken some of the guesswork out. I want
Yeah.
to just talk for a moment about homocysteine, and I want to talk
Hmm.
about it. We've been measuring homocysteine for the past 2 decades, really because of the correlative research demonstrating relationship between higher levels of homocysteine and risk for Alzheimer's and vascular issues as well of the brain.
Yes.
Might it not be? And the explanation I think we took from the work from a 2012 publication, New England Journal of Medicine, that talks about homocysteine ultimately becoming homocysteic acid, which is a mitochondrial toxin. But might homocysteine then be a proxy then for
Hmm.
lack of availability of methyl donors, in terms of, because that's how we remedy homocysteine. We give the methyl donors B6, B12, folic acid. But might it not be a proxy for deficiency of this whole methylation process because of the lack of methyl donors, which to some degree you remedied with your nutritional intervention?
Yes, I absolutely think that it is. It's a great surrogate marker. High homocysteine has been associated with hypomethylation of the genome, of DNA methylation in particular. So yeah, it's definitely a good surrogate marker. And it's not it. I don't know that it suggests that we therefore turn to a high dose, folate and B12 supplement alone, though. I mean, there was a really interesting study that I talked about in my paper, the B Proof study, where they gave, so these were hyperhomocysteinemic older folks. They gave them who were at risk for osteoporotic fracture. And there was some suggestion that B vitamins would help, and they would lower homocysteine. It was really pretty interesting study. And so they gave them a modest amount of folic acid and B12, and they in the oldest population. So when they sort of they did a secondary analysis after. So the initial intervention, really, the B vitamins didn't make a difference in fracture risk, unfortunately. And in addition to that, in folks who were oldest in the population, they actually increased their risk of colorectal cancer.
Mm.
So my question there is, and that's not the only study to suggest that. So, and my colleagues have challenged me. They said, well, they're using folic acid, or, this is a secondary analysis. Maybe, is it reliable? I mean, it's just an association. I mean, but there are enough studies coming out, and we know that if there's cancer present that hasn't been identified, that it is going to be grabbing the methyl groups available and turning off tumor suppressor genes and so forth. And so, is there a time when we want to be a little bit more mindful about it? And again, I come back to thinking about giving the the regulators, the curcumin and green tea, in all of our patients, and especially in those who might be vulnerable to quote unquote aberrant DNA methylation. And that would be, first and foremost, those who are older.
Well, I think you make a very good point. I mean, it's getting back to not only above all do no harm, but the ability to take a step back and say, we've been doing this for a long time. Old habits die hard, but uh, maybe we're not doing the right thing. I mean, how difficult was it for us to get off the low-fat bandwagon when that was
Right.
inculcated into our minds for
Right.
basically decades, that fat was somehow villainous, and now we realize what went on behind that. Let me go back to the microbiome for just a moment because a thought comes to mind, and that is the role of beneficial bacteria in terms of B vitamin production. So if
Yes.
indeed many of these B vitamins that are involved in being methyl donors and enhancing this methylation process, might not there be a strong connection with dysbiosis or threats
Yeah.
to our gut bacteria imposed by various other aspects of our environment that may ultimately serve to end up as declining our health span based upon changes in methylation of our DNA.
Yeah, absolutely. And I think that has already been suggested in the science. Yeah, I absolutely agree with us. Yes, with you. Yes. And it's so again, start with the gut, as we say, right? Yes, we can go a long way to restoring sort of total body systems wide health by optimizing our microbiome. And indeed, our microbiome produce really most of the B vitamins.
It's a very, very big and comprehensive picture, isn't it? And it's something that gratefully functional medicine has allowed us to embrace over the years, created kind of a safe place for us to embrace, the magnitude of these influences, the matrix, as
Yeah.
Dr. Bland and Dr. Jones over the years have, they created this matrix idea that everything seems to be related, and it's so challenged by how medicine is practiced in the Western world of being exceedingly linear.
Yeah. Yeah. I just feel deep gratitude towards being trained by them. This diet is this whole the program that we designed is really a tribute to being deeply steeped in functional medicine, to
Mm.
be able to think about the biochemistry, the total body influence, to design this program took, the freedom of asking questions as we're taught in functional medicine and translating the science to clinical application.
So, Dr. Fitzgerald, taking this graph from your study as it relates to what we've been talking about, the ability to basically bring about age reversal, walk us through your findings and what is shown on this graph.
Yeah, very exciting for us. Just really very exciting. This is our first publication, and we intend to dive into the data and publish more, and continue to research it. Let me tell you that this was a pilot study, and we are already looking at our next study design. So in our population, in those that participated in the diet and lifestyle intervention, as compared to controls, they got over 3 years younger. Their biological age was lowered by 3.24 years as compared to controls. When we compare our study group to themselves at baseline, or the within group comparison, they got almost 2 years younger as compared to their baseline, and that was a strong trend towards significant at 0.066. So we couldn't be happier with what we found, and are just gleeful to continue to study it.
I'm gleeful. I like the word. So, in the 8 weeks, 8 week interventional trial, who can't do eight
Yes.
weeks of telling people to eat in a different way, to get some exercise, do a breathing a technique, pay attention to their sleep. You demonstrated a dramatic, basically, can we say, age reversal?
Yeah, I mean, I want to continue to study it, but yeah, I mean, it was 8 weeks, and the turnaround was compared to controls, over 3 years. I mean, that's not just slowing age down. That appears to be reversing biological age.
It's really about, creating the safe place for people like you
Yeah.
to be able to blossom and move forward to really make a powerful, powerful contribution, which this study I think really is. I think this is a landmark
Thank
study,
you.
and I can't wait to see what comes next from you and your lab and your clinic because you're doing great work.
Thank you so much. It's just an honor to be with you.
Well, we'll talk soon,
Thanks.
and thank you for spending time with us today, Dr. Fitzgerald.
My pleasure.
Well, what did we learn today? We learned about this really incredible technology which looks at our DNA in terms of the changes that it has accumulated over time, the methylation pattern, the binding and the release of these methyl groups in specific patterns that relate to our biological aging as a very important metric that is used by researchers really around the globe now to assess aging, assess impact of interventions on how they may play out in terms of the whole aging process. Further, we looked at Dr. Kara Fitzgerald's study that she just published that looks at how this specific array of lifestyle interventions, including attention to sleep, breathing exercises, exercise, and diet, can, in this case, quite dramatically over an incredibly short period of time, just 8 weeks, affect the Horvath clock, the DNA methylation pattern, and it's really remarkable. We will look forward to connecting further with Dr. Fitzgerald in the future. We know that she'll certainly continue to explore how lifestyle changes can affect this Horvath clock DNA methylation pattern and what the implications are for aging and certainly for increasing our health span. I'm Dr. David Perlmutter. As always, thanks for joining us on The Empowering Neurologist, and we will be back soon. Bye for now.